My name is Patrick Lestrange, and my project is called Gefilter, and it's all about finding topics and customer reviews of products on Amazon. So let's say you're in the market for a wall mount for your television, and you visit Amazon's website. You'll find a section of a page for a product that lets you filter reviews by keywords. But there's a lot of redundancy in this feature. There's several versions of the word install, several versions of the word mount, and several buttons for the hardware you would use to set up the device. Beyond all of this redundancy, you also don't get a clear idea of whether customers are saying positive or negative things. Is it easy to install or is it difficult to install? This is unclear, and it slows down the customer. It also forces them to scan through several reviews to find relevant information. My product is a Chrome extension that will take this section of the page, remove it, and replace it with something simpler. My product retains the same useful topics from the previous feature, but in a much more concise format. And it also summarizes customer sentiment by adding emojis to the buttons. Let's see how it works in practice. If we visit the Amazon page for this product, I have my Chrome extension running. There's a little fish up here in the corner. We can click on one of these buttons, which will take you to my website. We'll get the reviews that correspond to this topic with the relevant portion highlighted for you. So, in order to build this product, I began with a large number of Amazon product reviews that I put into a Postgres database. And then I did a lot of the data manipulation with pandas. I needed to determine the important features to define topics for each set of reviews. I did that by first breaking the reviews down to their individual words, removing the less important stop words, and then breaking these words down into their base phrasing. So the word broken becomes break, and reordering becomes reorder. I then embedded all of these words in a numerical space with TF-IDF, which elevates the importance of less common words. Once the reviews for a product were all in this space, I identified the topics using non-negative matrix factorization. This returns a set of words that define a topic, which then become the words on the buttons in my Chrome extension. For example, I have this review for the topic install easy. I also wanted to isolate customer sentiment about only the identified topic. So I summarized each review, focusing on the identified topic, and fed that portion into a pre-trained sentiment analyzer called Vader. This returns a value defining the sentiment of that portion of the review, which then becomes an emoji on each button. For the sentence, I get a value of 0.58, which gives me a thumbs up. Next, I wanted to compare the original feature with Gefilter. So I measured how well Gefilter reduces redundancy in the buttons the customer would interact with. The function I have returns a value in the range of 0 to 1. To give you a feel for how this works, the list install easy TV would be 0, since all the words are unique, and the list install installed installs would be 1, since all the words are pretty much the same. For this TV wall mount example, I get a value of 0.14 for the original feature on Amazon, and 0 for Gefilter, since all the words are unique. This is a 100% reduction in redundancy, but on average, it's a little more than 15% across all the products that I tested. To tell you a little more about me, my name, again, is Patrick Lestrange, and I got my PhD at the University of Washington in chemistry. While I was there, I was developing algorithms to describe how molecules interact with X-ray lasers. When I'm not working as a data scientist, I like to run a lot. This is me at my first marathon. I also learned a little bit about how to sail over the past summer, and I like to build furniture in my spare time. Thank you.